Welcome back, everybody, for another deep dive. This time, we're going to be looking at mathematical reasoning in large language models.
Ah, yes.
These AI systems that generate text, it's like eerily human-like.
Right.
And we have a paper here to help guide this discussion from the Alibaba Group's Quinn team, and it was just published today.
Oh, wow.
It focuses on building something called process reward models, or PRMs.
Very cool.
So to kind of set the stage for our listeners out there, LLMs, they can do some pretty amazing things.
Oh, yeah, for sure.
But when it comes to math, sometimes they kind of, they still mess up sometimes.
Yeah.
Like they might get to the right answer, but the reasoning, the way they got there is just totally wonky.
Exactly. It's like that student who, maybe gets lucky on a multiple choice test.
Right.
They get the points, but they don't really understand the underlying concept. And this is where these PRMs come in. They're designed to guide the LLM, not to just the right answer, but to the right process. For solving the problem, it's like providing step-by-step guidance to make sure the LLM really grasps those mathematical principles.
That makes sense.
Yeah.
So how do they actually build these PRMs? What does that training process look like?
Well, one common technique is using Monte Carlo estimation.
Okay.
Basically, they give the LLM a problem, let it try to solve it a bunch of times.
Okay.
Then they look at each step in the process and see how often it leads to the correct answer. The more often a step leads to success, the higher its reward.
So you're basically reinforcing the steps that lead to that outcome you're looking for.
Yeah, exactly. It's kind of like, giving a dog a treat for good behavior.
Right.
But here's the thing. The researchers actually found some pretty significant limitations with this Monte Carlo approach.
Okay, this is where it gets interesting. Tell me about these limitations.
Well, one of the main challenges is that Monte Carlo estimation relies on the LLM's ability to actually get to the right answer.
Yeah.
Which, as we've said, isn't always a guarantee.
Right.
Sometimes a flawed process might accidentally lead to the right solution.
Okay.
Or a valid process could get thrown off track because of like a tiny little error.
Oh, I see.
And this can really mess up the whole reward system.
So it sounds like the reward model is only as good as the LLM it's based on.
Exactly. It's like a bit of a chicken and egg problem.
Yeah.
And that's not even the only issue.
Oh, there's more.
The standard way of evaluating these PRMs, which uses something called a best of n strategy,
Okay.
can also be kind of misleading.
Now, for our listener who might not be up on all this jargon, what does that mean, best of n?
Sure. So basically, you have the LLM generate like a bunch of different solutions to a problem.
Yeah.
And then the PRM picks the one with the highest score.
Got it.
But this approach can sometimes end up favoring LLMs that basically just get lucky with the right answer, even if their reasoning is like totally flawed.
So it's kind of rewarding the outcome over the process.
You got it. And that kind of goes against the whole point of using a PRM.
Totally. So what did the researchers do to deal with these issues?
Well, they got creative.
Okay, good. I was worried there for a second.
One thing they tried was using a different approach. They had another LLM, a more powerful one, act as kind of a judge to assess the correctness of each step in the process.
So it's like having a teacher actually check the student's work along the way.
Exactly. Instead of just grading the final answer.
Now that's interesting. So did it work better?
It showed some real promise, but they actually found an even better strategy, combining the two approaches.
Oh, wow.
They came up with this really cool consensus filtering thing where they only kept the training data if both the Monte Carlo estimation and that LLM judge agreed on which steps were right or wrong.
So basically, they're double-checking the AI's work.
Exactly, making sure the training data is super accurate.
Now, that's smart.
Yeah.
And what about that whole outcome over process problem?
So to avoid that bias, they brought in another layer of testing this time, using a benchmark called Process Bench. And this one specifically focuses on the LLM's ability to, pinpoint errors in the reasoning steps.
Interesting. So what was the big takeaway here? Did all this effort actually pay off?
It totally did. They were able to train this PRM that just blew existing open source models out of the water.
Wow.
Not just in terms of getting the answers right, but in actually identifying reasoning errors.
So this is a pretty big step forward.
It really is. This is making LLMs way more reliable and trustworthy when it comes to math.
That's a big deal. So I think we've covered a lot of ground here. But before we move on, I want to touch on something that the researchers mentioned in their paper. They talked about something called an outcome reward model, or an ORM.
Okay.
How are these ORMs different from the PRMs we've been discussing?
So RMMs are a bit simpler. They only care about the final answer, right or wrong.
Right.
They don't really look at the steps involved in getting there.
So it's like a pass-fail system versus a detailed grading rubric.
Perfect analogy.
Got it.
Yeah.
So why did the researchers choose to focus on PRMs instead of these ORMs?
Well, they believe that this step-by-step feedback is really crucial for developing true mathematical reasoning in LLMs.
Okay.
ORMs might help the LLM get the right answer,
Right.
but they don't necessarily teach it to understand the logic behind it.
I see. So it's the difference between memorizing a formula and actually understanding the concepts.
Exactly.
Okay.
And that's why they think PRMs are the key to building these AI systems that can not only solve problems, but actually explain their reasoning to us humans in a way that we can understand.
That makes sense. That's really fascinating. So what's next for this research? What are some of the potential implications of this work?
Well, imagine AI that can help mathematicians prove theorems.
Wow.
Or scientists analyze these huge, complex data sets.
Yeah.
Or engineers design totally innovative new technologies.
The possibilities are pretty mind-blowing.
They really are. And what's even more exciting is that by studying how these AI systems learn to reason, we might actually gain new insights into how our own minds work.
That's incredible. So we're using AI to better understand ourselves.
It's like this amazing feedback loop.
That is really cool.
Yeah.
But obviously, with any powerful technology, there are going to be potential risks and ethical considerations.
Of course.
That we need to think about.
Absolutely.
As AI becomes more and more integrated into our lives, we have to make sure that it's being developed and used responsibly.
Definitely. In a way that benefits all of humanity.
This deep dive has given us a lot to think about.
It really has. It raises all these questions about the nature of intelligence, the future of learning, and the potential for human AI collaboration.
For our listeners out there who want to dig a little deeper into this topic, we'll be sure to include a link to the full research paper from the Quinn team in our show notes.
Yeah, it's a really fascinating read and gives you a glimpse into the cutting edge of AI research.
And as always, we encourage you to continue your own exploration of this incredible field. Stay curious, keep questioning, and keep diving deep.
Because the future of AI is something we're all creating together.
Well said. Well, that's going to do it for this part of our deep dive into mathematical reasoning and LLMs. We'll be back soon with part 2, where we'll explore some of the challenges and opportunities that lie ahead in this rapidly evolving field.
We'll see you then. So where we left off, we were talking about how the researchers were trying to overcome some of those limitations with Monte Carlo estimation and the whole best of n evaluation thing.
Right. They were experimenting with this idea of using a more powerful LLM as kind of a judge.
Yeah, like having another set of eyes to make sure the training data was on point.
So did that end up working better than just relying on the Monte Carlo method?
It definitely showed some promise, but get this, they found an even better strategy.
Oh, now I'm intrigued. What did they come up with?
They decided to combine both approaches. They called it consensus filtering.
Okay, I'm listening.
Basically, they only kept the training data if both the Monte Carlo estimation and the LLM judge agreed on which steps were correct.
So kind of like a double-check system to make sure the training data was super accurate.
Precisely. That way they could be more confident that the reward model was actually learning the right things.
That's pretty clever. And what about that whole issue of the evaluation method favoring outcome over process?
Right. So to address that, they incorporated another layer of testing using a benchmark called process bench.
Process bench. Okay, I've heard of that one. But for our listeners who might not be familiar, can you give us a little rundown?
Sure. So process bench is specifically designed to evaluate an LLM's ability to actually identify errors in reasoning.
Oh, interesting. So it's not just about whether the LLM gets the final answer, right?
No, it's about making sure the LLM is thinking through the problem logically and can pinpoint where things might have gone wrong.
That's a really important distinction. So at the end of the day, did all of this effort actually pay off? Did they manage to create a better PRM?
They absolutely did. The PRM they trained using this combined approach consistently outperformed existing open source models.
That's impressive.
Yeah. And not just in terms of getting the right answers, it was also significantly better at identifying reasoning errors.
So this is a big step forward in making LLMs more reliable when it comes to mathematical reasoning.
For sure. It's all about making sure these AI systems are not only smart, but also trustworthy.
It makes you wonder if this whole approach of focusing on process over outcome in AI training could have broader implications beyond just math.
Right, because in the real world, it's not always enough to just get the right answer. You need to be able to explain how you got there and why your reasoning is sound.
Exactly. Especially if you're dealing with things like medical diagnoses or financial decisions where the stakes are high.
Absolutely. So this research really raises some interesting questions about the future of AI and how we can ensure that these systems are not only capable, but also ethical and aligned with our values.
This has been a truly fascinating deep dive so far.
Yeah.
And I can't wait to see what other insights we uncover in the next part.
Me too. This is just the tip of the iceberg when it comes to exploring the potential of AI for mathematical reasoning.
I'm ready to dive even deeper.
Let's do it.
You know, it's amazing to think how far AI has come.
Yeah, in such a short time, it's really incredible.
And this research that we've been discussing from the Alibaba Group, it really highlights just how important it is
Yeah.
to think about training AI systems not just for accuracy,
Right.
but for genuine understanding.
For sure. It's not just about getting the right answer. It's about understanding why it's right.
Exactly. It's like we're moving towards a future where AI can truly reason, explain,
Yeah.
and collaborate with us humans in really meaningful ways.
Absolutely. And think about what that could mean for things like scientific discovery or solving those really complex problems that we face as a society.
Like climate change or developing new medical
Oh,
treatments.
exactly. The possibilities are just endless.
It's mind-blowing. But of course, as we talked about before, we have to proceed with caution.
Of course.
We need to make sure that AI development aligns with our values and that these incredibly powerful tools are used ethically and responsibly.
Couldn't agree more.
So where do we go from here? What are some of the big questions that this research raises for you?
Well, for me, it really highlights the importance of continuing to explore different approaches to AI training.
Yeah.
Like these process reward models, we need to find ways to incentivize AI systems to not just learn, but to truly understand.
And to be transparent about their reasoning process.
Absolutely. Because at the end of the day, we need to be able to trust these systems if we're going to integrate them into our lives in a meaningful way.
This deep dive has given us a lot to ponder, hasn't it?
It really has. It's sparked so many new questions about the nature of intelligence, the future of learning, and the incredible potential for collaboration between humans and AI.
I think that's a great place to wrap up this episode of Deep Dive.
Yeah.
For our listeners who want to explore this topic further, be sure to check out the full research paper from the Quinn team.
We'll include a link in the show notes.
And as always, we encourage you to keep learning, keep questioning.
And keep diving deep.
Because the future of AI is a story that we're all writing together.
That's right. Thanks for joining us.
And we'll see you next time for another fascinating exploration of the frontiers of knowledge.